Okay, so today we're going to be talking about taking all that information. We've already talked about free fall. We already did a lab where we created these graphs. All right, and I just gave you your labs back. So I would have those out and handy. If you don't have them out, pull them out now. Okay, here we go. So we created these graphs before. We've got two graph types. We've got a position graph where we see the ball goes up and then comes back down again. We've got the velocity graph, which actually shows the same trajectory. Starts off with a positive velocity, then this is the velocity at the top of the flight, and then the velocity goes negative as it comes back down. All right? So the first question I have for you is, when is the velocity zero? And if I ask when, what am I talking about? Time. At what time is the velocity zero in these graphs? Take a look. When is the velocity zero? And go ahead and write that down in your notes. Okay, so if I want to know when the velocity is zero, that happens to be this time right here, right? So on the velocity graph, that's at 3 seconds, the velocity is zero. And I also, if I look up at the position graph, that also makes sense because that's the top of the flight. The ball isn't going up anymore, and it hasn't yet begun to go down. So velocity is zero. At the top of the flight. When speed zero, same answer, top of the flight. 3 seconds. All right, next one. There are two questions. The first question is, for each of these three time intervals, when, let's see, the questions are, wait, what are the questions again? Is the object speeding up or slowing down? And is the acceleration positive or negative? So go ahead with the person you're sitting next to. See if you can figure out the answer for these three time periods, the next few questions. Okay, from 0 to 3 seconds, that's actually the first half of the flight. Let's see, so I started with this positive velocity and the velocity goes to 0. So let's take a look. The first half of flight, let me erase all these. Oh no, I can't erase. Anyway, it looks like the ball is slowing down on the way up. But is that a positive or negative acceleration? That's negative. Well, how do I get acceleration? That's just the slope, but that slope is negative, right? Slope of the velocity graph is the acceleration. It's a negative acceleration. Next one, at the very top at 3 seconds, what's the acceleration? Negative. On the way down, uh-oh, there we go. Wow, this is touchy. Okay, on the way down, of course it's speeding up, but again, what's its acceleration on the way down? Negative. What do you notice about the acceleration the entire time? Negative. Why? What's pulling it down? Gravity. Gravity always causes that negative acceleration that you see. So the negative acceleration doesn't really mean that it's speeding up or slowing down. The negative acceleration means the slope of the velocity graph is a negative slope. Got that? Even right here, when the ball's at the very top, what's the acceleration? Negative. The velocity is 0, but the acceleration is negative. You guys got it? All right, so we're going to use these ideas to solve problems. And that lab that you guys did where you threw the ball up in the air, we can use these as given quantities. So here's the problem-solving givens that you need to know. First of all, what is the acceleration always in free fall? Negative how much? Negative 10 meters per second squared. Turns out we did a little bit, we've done this experiment a number of times, and if you do it really, really carefully, you'll see that the acceleration is not negative 10, but it's actually a little less. It's negative 9.8 meters per second squared. And let me throw a negative in front of that. So it's negative 9.8 meters per second squared, which means down. All right, what's the velocity at the top? How fast is the ball going at the top of its flight? If you throw it straight up, give me a number. Yeah, it's always 0. So velocity is always 0 at the top. So these make up the given quantities. Whenever you're doing problems where you have objects in free fall, you always know that the velocity at the top is 0. The acceleration is always negative 9.8 meters per second squared. You, of course, it's an accelerated motion problem, so you can use the 4 acceleration equations. The last thing you're going to need to solve problems is a trajectory. And what I mean is, if you have a problem where you're going to use the way up, when is the velocity 0 again? At the top. So if you use the way up, guess what? Your final velocity is 0. What if you drop a ball? When's the velocity 0? The initial velocity. On the way down, the initial velocity is 0. But if you took a ball and threw it up in the air, straight up, is the velocity at the bottom 0? Right after you throw it. Is the velocity of the ball 0? No, of course not. It's moving. Otherwise, it wouldn't leave the ground. Is the velocity right before it hits going to be 0? Of course not. If it were, it wouldn't hit the ground. But there is something else that's 0 if you throw a ball up in the air. Here's your hint. The ball starts from the ground and lands on the ground. What quantity is 0? Displacement. So, depending on your situation, you're going to pick one of these 3 trajectories. The way up, the way down, or both. And something is going to be given to be 0 in that problem. You guys ready? Let's do one. All right. So, scroll down to the next page, and let's try a problem. Okay. Example 1. An object's dropped off a 10-meter high cliff. How long will it take to hit the bottom? Okay, before we even begin, what trajectory do you want to use? Pick one. What do you think? Initial velocity 0. So you want to use the way down? All right, so let's try it. That makes sense to me. Okay, so what are your givens? Go ahead, do that now. Okay, so once again, givens A, D, and VI. A is negative 9.8 meters per second squared. D is negative 10 meters. VI is 0. T is the unknown. You should pick an equation that works with all 4 of those variables and end up with an answer of approximately 1.43 seconds. All right. We good? Any questions? All right. Go ahead and try example 2 on your own. So when you're doing problem 2, you've got to tell me what trajectory you want to use first. That's really the first thing, right? Because that will tell you what givens you're going to end up using. I'm going to be looking, when I grade these questions, I'm going to be looking to see that you wrote down what trajectory you're picking. All right? Because that trajectory, once you pick that, then I'll check to make sure whatever you picked for your trajectory matches your given. All right? So here's what I ended up with. I used the way up. I used an initial velocity of 20 meters per second. Final velocity at the top is 0. Acceleration is negative 9.8 meters per second squared and comes out to be 20.4 meters high. All right, and that is it.